Hey there, I've prepared some exercises to review the final exam of PreCalc. Let's go. So let's begin with Unit 5. I've got a couple of matrices here, and we're gonna perform the following missions. First of all, 2a minus 3b. So 2a is a times 2, so that's, I'm gonna do it here, 4, 6, 2, 4, and I'm gonna subtract 3 times b, so 3, 0, 6 minus 9. Alright, if we subtract this, we'll get 4 minus 3, 1. 6 minus 0, 6. 2 minus 6, minus 4. 4 minus 9 is 4 plus 9, so 13. That's the answer. Okay, done. Next one, 3b plus x equals a plus a. Let's develop this equation. So we've got 3b plus x equals a plus a, which is 2a. Alright, how do I get rid of 3b? Okay, to cancel 3b, I need to subtract 3b. And when we're adding or subtracting, equations with matrices work pretty much like equations, ordinary equations that we know with real numbers. So I could do minus 3b plus 3b plus x equals minus 3b plus 2a. Alright? Let's keep in mind that it matters the position where I put this. Now, minus 3b and 3b, they cancel. So what I've got is minus 3b plus 2a. And we know that adding is commutative, so we can just do, what is going on? We can just do that x is 2a minus 3b, and we already know what 2a minus 3b is because we did it before, so this would be also x. Nice. Next one. Inverse of a. We want to find its inverse, so we're going for this. Okay, so somehow we want to end up having this on the left. Let's begin the puzzle. I'm gonna go for the zeros first. So first idea that comes into mind is multiplying this by 2. If I do this, I'll get 2, 4, 0, 2. Why did I do this? Because now I can just subtract row 1, and I'll get rid of the 2. I'll get my first 0. So 2, 3, 1, 0. 2, 3, 1, 0, and 2 minus 2, 0. 4 minus 3, 1. 0 minus 1, minus 1. 2 minus 0, 2. Alright, now let's go for this 0. I've got a 3 here, so I'm going to multiply this by 3. Let's get it. 2, 3, 1, 0. 0, 3, minus 3, 6. Now I'm going to subtract the row 2. So I'll get 2 minus 0, 2. 3 minus 3 is 0. That's what I wanted. 1 minus minus 3, careful, 4. 0 minus 6, minus 6. And here I've got 0, 3, minus 3, 6. Okay, we're almost done. It's looking a lot like this, but I need some 1s, so I'm going to divide this by 2, and I'm going to divide this by 3. Therefore, what I get, I'll write it here, I'll get 1, 0, 2 minus 3, 0, 1, minus 1, 2. So the inverse of a is this pretty thing right here. That's what we're looking for. 2 minus 3 minus 1, 2. Okay. So the answer is 2 minus 3 minus 1, 2. Notice how it's the same, but with these two, with sign change. That isn't the rule that you can apply always. That's just one case in particular. Coincidence. Alright, now let's solve this equation. Ax equals b. We want to get rid of a, but a is multiplying x. That's more complicated with matrices. How do we get rid of it? Multiplying it with its inverse. So in order to solve this, I'll do a inverse times a times x equals, and now be very careful because when we multiply with inverses, order really matters. So if I put the inverse of a on the left, I gotta put it on the left as well. Okay, so now we get rid of this, and x is the product between the inverse of a and b. So let's do that. Inverse of a, 2 minus 3 minus 1, 2. And b is 1, 0, 2 minus 3. If we multiply them, we get, remember we're doing row times columns. So row 1, column 1. That's 2 times 1, 2. Minus 3 times 2, minus 6. Okay, next one. 2 times 0, 0. Minus 3 times minus 3, plus 9. And I'm going to continue. Minus 1, plus 4, 0, minus 6. So the result is 2 minus 6 minus 4, 9, 3 minus 6. So that's the solution we were looking for. We found x. Alright, if you understood all of this, you got this unit covered in your pocket. Okay, next one. A windmill has 4 blades that measure 1 meter and complete 1 revolution every 30 seconds. Nice. The center of rotation of the blades is 4 meters above the ground. We are tracking the positions of the extreme of a blade, so like the position of this extreme, for example. Epa, what's going on? Hey, stop. Here. With the following function. ht equals a sine kt plus m, where h is measured in meters, that's important, okay, and t in minutes. Let's begin by setting up the drawing properly. We know that every blade, we're assuming that they're congruent, every blade measures 1 meter. And from the center of rotation to the ground, there are 4 meters. The drawing is not in scale, obviously. Okay, we also know that 1 revolution, so 1 full loop, is completed every 30 seconds. Careful, we don't want it in seconds, because we're gonna set up our function later in minutes. So 1 revolution is every 0.5 minutes. Alright, that's better. Let's find all the values. So I'll begin with finding A. A is the amplitude. Is the value that defines from its axis of symmetry how far it goes, up and down, right? The standard amplitude of a sine wave is 1, because the axis of symmetry is on the x-axis, and it goes from 1 to minus 1. So amplitude is 1. For this one, this point right here is going to complete the following shape. No, it's gonna move like a circle, and it will go, since the radius is 1, its minimum value will be here and its maximum here. So from its center of rotation it goes 1 unit down and 1 unit up. So the value of A is 1. What about M? M is how much we have translated the axis of symmetry. If the ground is here at 0, this is the ground, h equals 0, we've translated the center of rotation, the center of the wave, to h equals 4. Therefore, m is 4. Alright, we've got A and M. Now we're only missing K. Okay. So K is the frequency of the wave. What is the usual frequency of sine? How often does sine complete 1 revolution? Sine completes 1 revolution every 2 pi units. And now we want it to complete 1 revolution every 0.5 units, right? Every half a minute, because we're measuring it in minutes. So we can set up the following equation. We want to go from 2 pi to 0.5 f. If we solve this, 2 pi divided by 0.5 should be f. If you input this in your calculator or you do it by hand, you'll get that this is 4 pi. So we have found the frequency. I've called it f here, but I've just realized that here I wrote a k. So let's write that down. K is equal to 4 pi. And now I'm going to sketch the drawing of this function. All right, this is... it's hard to do a straight line. Okay, let's sketch it. So the wave is 4 meters above the ground here. Stop. This pen is not good. Okay, so the wave starts here, 8 meters above the ground, and goes 1 unit up, 1 unit down. It's a sine wave, so it starts at the middle, and it does something like this. Alright, so it goes to 5, position 5, and 3. And completes 1 revolution, 1 full loop. Sorry, the full loop is here, my bad. 1 full loop every 0.5 seconds. This is time, and this is the height. Alright, exercise completed. Let's go for the last one. I've got here a bunch of stuff. Let's find. First of all zeros of p. P is a polynomial of third degree, so it's going to have 3 solutions, either real or complex. I'm going to start by finding a real solution, because I haven't taught you how to find 3 complex solutions of a third degree polynomial. So it's most likely that the first one is real. So I'm going to set up Ruffini, or synthetic division, however you call it. I write down the coefficients of my polynomial. And now I'm going to try to find a value that works. Alright, let's try a couple of values. By the way, if this last number is a 2, it means that the solution, if it exists, it must be a divisor of 2. I'm going to try 1. Okay, 1. 1 times 1, 1. 2 plus 1, 3. 1 times 3, 3. 4, 4. It doesn't work. We don't get to 0. Probably I'll need to try a negative. I don't know. Let's try minus 1 now. Minus 1 times 1, minus 1, 1. Minus 1, 0, 0. Oh, it doesn't work. We don't get to 0. Let's try another value. I honestly don't remember what's the solution. So let's try a 2. 1. Wait, sorry. Let's try a minus 2. 1, minus 2, 0, 0, 1, minus 2. It worked. So minus 2 is a solution. And the remainder that we get is this. Let's analyze this polynomial. Number, x, and x squared. This polynomial is x squared plus 1. To find the solution, I'm going to make this equal to 0. And I'm going to solve it. I don't even need to use the second degree equation formula, because this is so simple. 1 on the other side. Square root with a plus minus. Usually we wouldn't know what to do with the square root of a negative number, but now that we're on the complex field, we know that square root of minus 1 is I. So that's it. We found the 3 solutions. Minus 2 is the real one, and then we've got I and minus I. Great. Let's move on. B, if k equals 4, express z in polars. So if k equals 4, z is 3 plus 4i. If I graph this, I'm going to graph it here. The complex number is here. 1, 2, 3, 1, 2, 3, 4. Remember, the real part goes here and the imaginary part here. So here's my complex number. In polars, I want the radius and the angle. I've got a triangle of sides 3 and 4. So how do I find the hypotenuse or the radius? I find it with Pythagoras. So 3 squared plus 4 squared, square root. And this is equal to 5. All right, what about the angle? The angle is I'm looking for this angle, right? The argument. The argument, I can do tangent, because tangent relates opposite with adjacent. So the angle will be 4 divided by 3. There we go. This is more or less 53 point something. I don't know. I'm not gonna do it. Okay. C. Find if. Wait, sorry. Once you find this, I'm gonna approximate this into 53 because I don't have a calculator right now. The polar form would be a 5 with angle 53. Okay, C. Find K if Z times W has an imaginary part of 1. Alright, let's see what is Z times W. Z is 3 plus Ki. So 3 plus Ki. And W is 2 minus I. 2 minus I. Let's multiply them. We've got 3 times 2, 6 minus 3i plus 2ki minus ki squared. Let's simplify this. We've got 6 minus 3i plus 2ki. I squared is minus 1, so minus k times minus 1, which ends up being just plus k. And they're telling us find k if the imaginary part equals 1. Let's see, who's the imaginary part? Here and here. So I want to make sure that when I add minus 3i with 2k, sorry, I'm not going to write down the i's. I want to make sure that when I add the coefficients, so minus 3 plus 2k, I want to get a 1. So let's solve it. The minus 3 on the other side, so 2k equals 4, so k equals 2. Okay, we found the condition. For the last part, they're asking us find k if z minus w has an imaginary part of 2. So let's do z minus w. Last part, z minus w. Z is 3 plus ki. Actually, I don't need brackets because I'm gonna, well, yeah, I'm just gonna write down the brackets. 3 plus ki, and I'm gonna subtract w, 2 minus I. Alright, let's develop this. 3 plus ki minus 2 plus I. Careful with the signs. And now the imaginary part must equal what? 2. So let's see, who's the imaginary part? This guy's imaginary, this guy's imaginary. So we want to make sure that when we add k with 1, because the coefficient of I it's a 1, we get a 2, right? I keep forgetting. Yeah, a 2. So that can only happen if k is equal to 1. So we found the other condition. Great, I'm so happy. What's going on? Okay. That's final answer, final answer, answer, and answer. Nice. I'm not going to review Unit 8 because I'm assuming that you'll have it fresh because you take the final after taking the Unit 8 test. If you need to review that, just watch that video. Good luck on the final. I have faith in you. All my faith is on you. May the light follow your dreams. See ya.